All right, so this is 2-3. Did you guys notice I fixed my board? You see that white thing that's above the screen? That's the touch sensitive part. I just unplugged it, so now it's not freaking out on this anymore. Yeah. So now it's just a display. But it helps us right now. So 2-3, we are going to talk about some really important things. First idea or concept. You don't have to write this. I just want you to watch this. This is me giving you kind of proof, and I'm not going to show you fully. I'll just give you the idea. Let's say I took this triangle, and someone took scissors, and they cut this corner piece right here. And someone else took this corner piece right here and cut it, and someone took this corner piece right here. And then we flipped the angles and we put them all together. So does everybody see this angle right here? Actually, we'll do this one. Does everybody see I'm copying it pretty close? That would be that one. So that's the first one that I just drew. Does that make sense? All right, can you flip this angle over? Angle 2, can you flip it over? Does everybody see it would look kind of like that? And then can everyone see angle 3 is right here, and that would be this angle? I'm telling you, if you cut out a triangle, what do you notice about all the angles? This is angle 1, this is angle 2, this is angle 3. Together, what are they going to form every single time? A straight line, which means the measure of all the angles of a triangle have to add up to what? That is our first theorem we're going to talk about today. The first theorem is called the triangle angle sum theorem. And basically, it's just stating A, B, C. If you take the measure of angle A and you add it to the measure of angle B and you add that to the measure of angle C, that will every time equal 180 degrees. It has to.
I forgot. What's the Pythagorean?
We are going to get there. A squared plus B squared equals C squared. We'll get there, but not this chapter.
Isn't that one have to do with triangles? Doesn't that one also have to do with triangles?
It does. Special triangles. Does everybody understand that theorem so far? All right, we got another theorem that I just want to put up here. If it was me, I'm going to star the junk out of that theorem. That is a very, very important theorem. We will use that all the time. This next one I'm going to put up is not as big a deal. I'm talking a star like this on your paper. You need to bring attention, like you need to know. Remember how I told you to make flashcards? That's one I might go ahead and make a flashcard for. This next one, not as big a deal. I told you I'm going to try to guide you through this, tell you what's really important, and then I'll show you some stuff, but this one's not quite as important. It says, through a point, not on a line, there is one and only one line parallel to the given line. So I will show you this on a word, or pictures, better than word. There's a given line. Whoops. Come on. Here's my given line. Does everybody understand that? There's a point that is not on that given line. What this theorem is stating is there is one and only one line that will go through that point that will also be what? It will also be parallel to this line down here. Technically, how many lines go through that point? Yeah, there's a line here, 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 here. It's like the genie when he's talking about the exits on the here, everywhere, right? It's like that. There are lines that go through this entire point, all different directions. But this theorem states there is only one line that will go through it that will be parallel to the line down there. That's what theorem 2-10 states.
Where's that theorem called?
That's what it doesn't get a name. That's why it's normally not as important. We call it theorem 2-10. That is its name. Like, what does it mean? The definition is through a point, not on a line. There is one and only one line parallel to the given line. So there's a given line, there's a point, there's only one line that goes through it that's parallel to the other one. There is one and only one line parallel to a given line. Just understand the concept. It's really not a big one. All right, let's get to using this stuff. I'm going to show you this one in easy way, and I'm going to show you the hard way. The reason I'm going to show you the hard way or longer way is because we need to start thinking like this in geometry. So this next problem is probably one of the biggest problems we're going to get to, and I am drawing it on purpose to kind of try to trick you. What are we not allowed to use in geometry, guys? Okay, I drew this on purpose, and most kids will fall trap to this. I told you that the measure of this is 32 degrees, correct? Because kids use their eyes, what do they assume? Are there any arc marks saying that those are the same? Is there any statement saying that those two angles, by the way, we'll call this Q, this R, this S, this T. Is there any statement up here that states that measure of angle Q, don't write this, TR, is equal to the measure of angle STR? Is there any statement up there right now that states that? So can we assume that those two angles are the same? Please start paying attention and looking at that, Julian, right? And seeing that those two things, we cannot use our eyes to assume that they are equal. All right, let's do this the easy way. Sometimes I told you in geometry, what are you going to have to do with figures? Something that is a common practice. Please take those glasses off. I think I'm going to have to call home. Why are we putting glasses on? Don't do that. Yes, I assume that you're closing your eyes underneath your glasses. What's an easy way to find this? We're trying to find X and Y, by the way. Can I redraw this? Does everybody see this triangle over here? Yes. What do I know the measure of this angle is? It looks like it's a right, but it's not. So don't use your eyes, Peyton. What is the measure of that angle down there? 78. What is the measure of this angle right here? X. What is the measure of this angle right here? So here is what my expectation. Yes, I expect you to redraw it on your homework paper tonight. It is in a good habit. You need to start practicing it. Practice when it's easy. Because if I practice when it's easy, then I will have good habits for when it gets tougher. Does that make sense? So 78 plus what? 32 plus equals, yes, I expect to see this on your paper. If this is what I do, then this is what I expect on your homework. If you just give me answers and you say, well, I used a calculator, what am I going to tell you? Sorry, I'm not taking your work, right? No work, no. Okay, you're going to add these two together. Can you use a calculator to add those two together? Sure, but when you add them together in your calculator, you're going to write what you get down here, which would be 110 plus X equals 180. Do you see how I'm using a calculator and still showing my work? Then I'm going to minus 110, and I get that X equals 70. So now I solve for X. Does everybody see? And if someone asked me, how come you know that these things added up to 180? What would I tell them? What would be my reason why? Triangle, angle, sum theorem, right? That's my vocab. If I was doing a proof, that would be my reason why I can state that. What would be my next reason? How come I can say that 78 plus this equals 110? What would be my reason? We call that simplifying. That would be my reason why. Simplifying. Whenever you actually do math, we call it simplifying. And then since I subtract 110 from both sides, what is that called to my next step? Subtraction property of equality, right? I'm just constantly talking about proofs so that they're not scary to us. The more we do them, I promise you, the easier it will get. Now, how can I solve for y? This is an old vocabulary word. Come on, heads up, boys. Let's go. Heads up, please. Thank you. What can I say? How can I use an old vocabulary word to solve for y? Come on. No. 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 I'm trying to solve for y. Come on. What? Kind of. Better than that. Nope. Nope. Oh, she said linear. She's on the right track finally. Oh, now we got it. Linear pair. Look, do these two angles form a straight line? So what are they called? Now, is that from this chapter? This section? Are we still using it? You've got to start unboxing your math, guys. You got to see whatever I teach you in the past, that can rear its ugly head whenever it wants to. And you have to, since it's been taught, you have to be able to use it later on. Do you follow what I mean by that? So we can go y plus 78 equals 180. That's not from this section. I can still use it though. And I get y equals 102. That's the easy way to do this problem. Does everybody understand that so far? Linear pair. Linear pair is when two angles together form a straight line.
That means that void right there is a right?
The 102?
Yeah.
Yep. Does it matter that it doesn't look like it's obtuse though?
No.
Doesn't matter what it looks like.
No.
Right? So we're trying to get that concept. It's a tough one to kick. I get it. It's very tough. That's why I go at it right away. All right, I'm going to show you this way. You know what? You don't have to copy this. I don't want you to copy this. Instead, I would rather have your understanding of this concept. This is so important that we learn how to start doing this. You know what, kids, a lot, remember, I have taught this class a lot. So when I sit here and I make predictions, it's because I've seen common errors in the past. And what I'm trying to do is I'm trying to keep you from making those common errors. So I'm trying to show you some techniques or bring things to your attention, not because I think you're stupid, right? But because I've seen common mistakes and we're trying to get away from those. One of the common mistakes that we talked about is kids, this looks like it's in the middle. They think they're both 32, which we just talked about at the beginning. We cannot assume that. Does everybody understand that? I talked about redrawing things, yes? All right. This is one thing that kids have a hard time with in geometry normally. How many triangles are up here? Do you see how I have two different answers? And some of you are like, there are two triangles. Well, watch this. Does everybody see this triangle 1? And most people see this triangle 2. Yes? But what about this big triangle? Does everybody see 3 triangles now? We have to start seeing figures like that in geometry because they're going to be figures on top of figures on top of figures, and we have to start. Basically what I did is I erased this line right here, and now that helps me see that 3rd triangle. Do you follow me? Do you see the 3rd one now? Do you see if I erase this line in the middle? There's a big triangle on the outside. That's the 3rd triangle. You have to be able to erase with your mind sometimes lines. Like, don't focus on, yes, I understand there's this line in the center. Scratch it out for a second. Now do you see the triangle? We're going to have to do that in geometry. Okay? So here's the long way. Again, I'm just trying to show you what, this isn't for this question, guys, but this is something that you will be expected to do probably on your homework tonight. Okay? We all understand how we got 70 for x. Does that make sense? You with me? Okay, let's look at this triangle right here. What if I was just trying to use the triangles to solve for this y? What if I didn't use linear pair? Well, isn't this 57 plus y? Do I know what the measure of this angle is right here? Okay, sometimes, please hear me. Please, 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 this is huge. You will have to solve for something they didn't ask you for. Sometimes in math, you will have to solve for angles they didn't ask you for to find the angles that they do want you to find. Sometimes you're going to feel like, well, why do I have to do it? You have to do more work. You have to do, they don't want this angle, but you have to find it in order to find the one that they want. Does that make sense? So they didn't ask me to find this angle, but I could find it. We're going to call that angle A. It's just another variable. I just picked A just because. Does everybody understand that? Okay. Does everybody see the big triangle? Notice I'm doing a lot of redrawing. Does everybody see the big triangle? What is the measure of this angle in the bottom left corner? What is the measure of this angle down here? 57. What is the measure of the angle that we found to be in the bottom right corner? 70. What is the measure of this angle? Wait, what'd you say? Does everybody understand the measure of this angle? If I define this as A, and this is 32, then the measure of the full thing is A plus 32. Do you follow me? Well, don't I know that 57 plus 70 plus A plus 32 has to equal 180. Are you with me? I can combine all these like terms down here. And when I do that, 57 plus 70, what is that? 127 plus 32. One what? And 157? No. This is a 7. Sorry, that's not a 50. That's my fault. That should be a 127. So what's 127 plus 32? Sorry. 159 plus A equals 180. Are you with me? Minus 159, minus 159. I figured out that A was 21. What does that mean for me over here? Now I know the measure of this is what? Did they ask me to find that? But can I now use that to figure out what y is? By the way, if you add this together, 57 plus 21 plus y equals 180, you are still going to get the same answer that we did when we did it the other way. Together, when we add these, this gets me to 78. And 78 plus y equals 180. And when I minus 78, what number pops out again? Y equals what? 102. Did I get 102 last time when I solved for y? Do you see how it was another way to solve for y? Why did I show you this way? Because I'm trying, no, this way I think is harder. Why did I show you this way? Is I was trying to show you how to imagine different parts, like there's 3 triangles, and sometimes you might have to use the big triangle to help solve for parts on the little triangle. Start being able to pull those pieces apart. Yes or no? All right, try this one. Everyone should have a piece of paper out. Everyone is trying this one on your own.
Actually, 2 triangles.
Mm-hmm. It is for a bow tie. Solve for X and Y. That is your job. Everyone should have a pencil in their hand and writing down, please. Let's go. 57. 42. don't have to draw the picture. If you just want to do the math, you can just do the math on it too. All right, what do I know in the first triangle? Don't I know that 57 plus what? 59 plus has to equal? And then together these add up to be? Let's say, come on, this should be a bunch of people answering this. Equals. Did I do this? Did I have you do this? Could you use a calculator to get that? Could you use a calculator? Yes. Do I care? But can you still show work even though you use a calculator? I am showing you how to show me your work. This is what your homework should look like. If it doesn't, again, I'm not being mean. These are my expectations. X equals, and then when I do that, what does it equal? Yes or no? Question, sir. No. That's not a bad question. What you're asking, a linear pair has to be together. They're a straight line, and there's like that. That would be a linear pair. Okay. All right. Now that I know that this is 64, this isn't in this chapter. But we're going to use something from chapter 1 that we've talked about. Because I know this is 64, what do I know? I know that this is 64 because they are called vertical angles. Do you see how every time I do something, I have a reason for it? When I do a proof, all I do is write the reason next to it. There shouldn't be any guesswork. You should have a definition of why you're doing what you're doing. And then we can say 42 plus 64 plus y equals 180. And we can add those together. And when we do, what do we get? 106 plus y equals 180 minus 106 minus 106, and we get y equals, and there's my two answers with my work shown, so Mr. Martin doesn't have to turn me away from my homework being turned in. Does that make sense? Okay, last theorem, I'm going to explain it to you again. Don't write it down right now. I'd rather you understand this theorem, and then we will write it down in a second. So this theorem right here states, okay, this is called an exterior angle. Please notice how you make an exterior angle. It is one of the sides continued on, and it's the angle from here to touching the other side. Do you follow me? Okay? Do you see my triangle? Do you see this line that I drew right here? Is that an exterior angle? No. Because if I take my side, do you see how I extend that on? Do you see if I take my side how I extend that on? Do you see how that line is neither one of those things? Do you follow me, yes or no? An exterior angle is an extension of one of the sides. That is an exterior angle. Do you see how it's going on? Do you get what I mean by that? If you connected this, what do they make? One of the sides is part of that exterior angle. Look, if I drew this one right here, you see that line right there? If I extended it, is it part of the triangle? Then it's not an exterior angle. So it's very important to know what an exterior angle is before we do this theorem. You see this exterior angle? We're going to call it 1, 2, 3, and 4. What do you know about angle 1 plus angle 2? What do they have to equal? Good. What do we know about angle 2 plus angle 3 plus angle 4? What do they have to equal? Good. What does that mean since this equals 180 and this equals 180? Doesn't that mean that angle 1 plus angle 2 has to equal what? Nope. Not 360. Look, this right here equals 180. This right here also equals 180. What does that mean about this and this? That they're the same. What in the world? Go away. That means that these two have to be equal. Do you follow me? Well, what do you see that both of them have? An angle what? So can I use the subtraction property of equality to get rid of that angle 2? And then what does that prove to you? The measure of angle 1 has to equal what? The measure of angle 3 plus the measure of angle 4. Does that make sense? That is what we're going to call, so here's the theorem. I just proved it to you. This is called the triangle exterior angle theorem. What's the most important part of geometry? Do you notice how much vocab we're going to get? This train ain't stopping. We're going to get vocab on vocab on vocab. That states, this is what this theorem states. The measure of angle 1 must be equal to the measure of angle 2 plus the measure of angle 3. What's the only thing you need to be careful of on this? This has to be a what kind of angle? And in order for being exterior, you could draw it, and do you see how it is part of the side of the triangle? So, I mean, an easy example of that would be something like this. How could I figure out what the measure of angle 2 is? Well, if I know this is 109, couldn't I take that and say, hey, 51 plus what? The measure of angle 2 has to equal what? 109. That's what that theorem states. And then you minus 51 minus 51, and it gets me angle 2 equals 58. By the way, what would be the long way to solve this? Because I know this, can I figure out what the measure of this angle is? And then I could add these two together, subtract from 180, and I could figure out this one. But this is supposed to be a shortcut. This works every single time. So this is supposed to be a shortcut. Instead of doing that long way, this is supposed to be a shortcut called the triangle exterior angle theorem. Questions on that? Try another one then. I wasn't talking to you. What is the measure of angle 1? Is angle 1 an exterior angle? Yes. If you extend it, do you see it's part of the triangle? So it is an exterior, so all I have to do is take 45 and add it to 75, and that equals the measure of angle 1, which when I add together is 120 equals the measure of angle 1. Please don't pack up on this last one. I don't want you to copy this. I'm just trying to preview. This is what some of your homework might look like. And please do not freak out. Use some of the things that I've showed you. How many triangles are up here? Tons and tons and tons of triangles. So like one of them says that this is 45. This is 55. This is 5. That's the angle 5. How can you solve for angle 5? Well, do you see that these together form a triangle? So doesn't 45 plus 55 have to add up with 5 to 180? Do you get what I'm saying there? And then it will ask you, to find this angle. It tells you that this one's 75. It asks you to find this angle. It asks you to tells you this angle. It asks you to find this one and this one. 1, 2, 3. Where's 4 at? It's gonna 1, 2, 3, 4, 5. There you go. It asks you to find those 4 or 5 angles on this shape. What do you think is going to be a good idea for you to do? Maybe solve for some of the angles, but also what is my big thing to you? When it looks crazy, what can we sometimes do? redraw and see if you can pinpoint what each one of these. You might have to use vertical angles. You might have to use the exterior angle theorem. You might have to use the sum theorem. You're going to use all those different theorems. There is a way to figure out every single one of these angles. Do you follow me? Questions on that? Okay. That will be your homework tonight.